Welcome to Chapter 1 and Chapter 2 review for our upcoming exam. So let's start with problem number 1, and I wanted to take this time uh, to kind of review how to do these rotational symmetry problems where you have a polygon and you're saying how many degrees you have to rotate it to get it to carry onto itself or map onto itself. So before we even read the question and answer it, I want to talk about how to approach these types of problems. And for the next, I think, 6 problems, there's going to be this chart here to serve as a reference. So when they talk about a pentagon, you know that's 5 sides. And it's going to look something kind of like that. So let's talk about how to determine what's the minimum amount of degrees you can spin that shape to have it land on itself. And in red, I've got this theorem or formula, and it says regular. Regular polygons are polygons with all equal sides. Okay, so regular polygons have a degree of rotational symmetry equal to 360 divided by the number of sides. So if I take 360 and I were to divide it by the number of sides, that will give me rotational symmetry. Okay, so I'm using a variable n to represent number of sides. So let's explore the rotational symmetry of an octagon. Using this formula to figure out the rotational symmetry of an octagon, it would be 360 divided by the number of sides. And in an octagon, there's 8 sides. So if I were to take 360 divided by 8, that would tell me my rotational symmetry. If I take out my calculator, I were to do 360 let's do this calculator. We'll do this real quick. Sorry about that. If I were to do 360 divided by 8, it says that my rotational symmetry is 45 degrees. So I go back, I go, oh, okay, it's got it. It's got 45 degree rotational symmetry. And I can kind of test that out. Here, I've got an octagon, and if I were to do a rotation, right? So if I were to rotate that object about that point 45 degrees, the shape lands on itself, and I'm going to color it red so you can kind of see that. It lands perfectly on itself. So that's how you do rotational symmetry. So let's take a look at the question now. This one is saying, what is the polygon? What is the regular polygon that has a rotational symmetry of 60 degrees? So if I view this as a relationship, as something I know is true, I can substitute things I know into it and solve for things that I'm looking for. I'm looking for the name of the polygon, okay? Because it's saying, like, what's the polygon? Well, if I were to figure out the number of sides in that polygon, I could then look at this chart and be like, oh, things that have 10 sides are called decagons. So what I do know is that this thing has a rotational symmetry of 60 degrees. So if I rewrite my equation, 360 divided by the number of sides, that's the thing I'm looking for. That must equal the amount of rotational symmetry. That must equal 60 degrees. And I'm going to turn this into a fraction, just 60 over 1. And I'm going to do some cross multiplication. Boom, 316 times 1 is 360. N times 60 is 60n. And I'm solving for n, so I just divide both sides by 60. Boom. 36 divided by 6 is 6. So I find that n equals 6. Our polygon has exactly 6 sides. So that is what we call a hexagon. So the polygon that will carry itself onto itself with a 60-degree rotation is a regular hexagon. And to summarize, you could set up this equation and solve it because it will work for both types of problems. You'll see in a second. Or you could have just done, take a look at what they give you. They say, look, your rotational symmetry is 360. If I were to just take that 360 and divide it by the rotational symmetry, it tells me the number of sides, right? Sometimes you're going to have problems where they say, here's the number of sides, right? If you were to divide by that, that tells you your rotational symmetry. So try that out in the next few problems, and if you need to check the work, you can skip ahead in your videos, but I'll see you in the next ones.